So refinery operations, refinery layout. Oh, okay. I got this, I think from research kit, if I remember correctly. So basically, in refinery, we have atmospheric distillation or crude oil distillation. Some of them will have vacuum distillation as well. And from crude distillation, atmospheric distillation, we will have a downstream unit such as hydrotreaters, catalytic reformer, hydrocracker, apa lagi? FCC, fluid catalytic cracker, and some may have delayed coker as well. So this layout will differ based on the refinery punya target lah. Because some refinery, their main the main goal is to produce diesel, and some of them they want to produce naphtha. So the layout will differ based on the product target. And I think same goes to the crude selection. Crude selection will also differ based on the product target. For instance, I think Arab heavy or Middle Eastern punya crude oil, they are very well known with heavy punya stuff. So if you want to produce more diesel, so we will have a crude from Middle East punya country lah. If we want more naphtha, so maybe we'll have it from, I don't know, from Malaysian punya crude oil, from Tapis ke, Bintulu, which is more light or lighter than the Middle East punya crude oil. All right. So this is a typical, I would say, refinery operation. It's not necessarily exact punya setup lah for refinery. Right, we start with crude distillation unit. So the main purpose of crude distillation unit is basically to separate, right? To separate the crude oil to a wide range of boiling point, product boiling point. So the separation based on difference in boiling point, and there'll be no reaction involved. And these are the typical distillation column, I would say. I think the distillation column might be the biggest one among these four tower. The rest is, I think, maybe a fractionator, I would say. So hydrotreating unit, main objective is to remove impurities. Impurities like sulfur and nitrogen in general. And also some of it is also designed for aromatic saturations. So for aromatic saturation, for instance, macam diesel, mana diesel, yeah. For diesel, diesel punya product spec is, I would say, an opposite to gasoline kan. So gasoline, we need higher octane number. Octane number basically an aromatic content lah. But untuk diesel punya spec is cetane index. So we need less aromatics. So that's the opposite lah. So for diesel hydrotreater, normally we also design it to saturate the aromatic content in the feed. So we need the paraffinic stuff, right? Previous, okay. So hydrotreaters involve chemical reaction. So when I said involve chemical reaction, meaning we have a reactor, right? So when we have a reactor, meaning we have a catalyst. So catalyst basically is needed to further optimize the energy usage or energy consumption. So just imagine, I think those who are from chemical engineering background, maybe aware. So catalyst is needed to reduce the activation energy of the reaction. So we need less heat to start the reaction. All right. For hydrotreaters, like I mentioned, consume lot of hydrogens, lots of hydrogens. Hmm. Okay. Ada. You have any question from the audience? Regarding this slide? Not that interesting. Ah. Oh, good question, Fahmi. How do we use the hydrogen? How do I put this? Um, um, do we burn them or pass to the feed? I'm not sure. Fahmi from chemical engineering punya background ke?
Yes, hello, sir. Can you hear me?
Yeah, Fahmi.
Yeah,
Yes.
I'm from chemical engineering background. So
Okay, good.
basically, this intrigues me. So I wonder, how do we use the hydrogen?
Okay,
Whether we
mm,
going to burn the hydrogen as maybe to make a reaction, or maybe do we pass, make a contact to the another gas, such as sulfur or nitrogen in this case?
okay,
Yes.
just imagine a chemical reaction, right? Chemical reaction. So we have a hydrocarbon with organic sulfur attached. Aku tak
Okay.
ada. Ya, boleh tulis tak agak sini? Pointer option pen. Okay. Sorry kalau tulisan tak cantik. Okay, kita ada hydrocarbon. Lepas tu kita ada organic sulfur attached.
I see.
Okay, so
Okay.
sekarang ni kita akan perlukan hydrogen to produce hydrocarbon plus H2S.
Okay.
Ni dia punya basic punya chemical reaction lah.
Alright. So it's like you removing the sulfur from the hydrocarbon branching.
Betul.
I see. Alright.
Yeah. Okay. So okay. Why I say hydrogen consumption is a lot, especially in more heavy punya stuff. So talking about diesel or this is vacuum gas or VGO, or other heavier punya products. Because okay, for instance, this is a straight change RS, kan? Tapi what if kalau kita ada aromatic compound? So aromatic compound ni, the heavier the crude is in term of boiling point. So let's say lah, so boiling point for crude, we have I think let's say from 24 up 30 and up until 360 ke lebih nanti 400 lah for instance. So at the heavier punya part, from contoh from 180 to 360, the aromatic content is a lot. So just imagine aromatic ring. Aromatic ring. So kita ada sulfur. So they will need more hydrogen to saturate the aromatics plus H2S. Kalau in this case, mungkin dia akan jadi instead of 1, mungkin dia akan jadi 5 of hydrogen to produce
Yes.
10 of
It
H2S.
depends on which ring do the aromatic compound have the sulfur, right?
Betul.
I see. Alright.
So untuk macam light stuff macam nafta is light lah. Nafta, so the aromatic content maybe not as much. So the hydrogen needed is less if compared to diesel punya hydrotreater. Okay. Alright. So we move to next question. Nak tanya apa pun tak tahu nak tanya. Oh, okay. Alif Ikhwan. Mechanical lah. No worries. We will get to that part later. So we will cover a bit on main equipments later on. Difference between sweet and sour crude. Sweet and sour crude. Sweet in term of the punya impurities lah. Sweet sulfur is less. Sour crude sulfur is more. Itulah dia punya lemon punya explanation. Can I have a quick brief on how to understand the PFD hydrotreating unit? PFD hydrotreating unit. Okay. Alright. Okay, Saji. Okay, if you guys interested, we can go a bit on this block diagram. This is not PFD, SRG. This is block diagram. PFD will be more details than this. So we start from crude oil. So crude oil, we have atmospheric distillation. So from atmospheric distillation, it will separate based on boiling point, right? So the lighter stuff will go up, and the heavier part, the heavier stuff will go down. So lighter stuff, basically, we're talking about gases, C3, C4, and then naphtha, and some of it will be kerosene or jet fuel. And then the heavy part will be diesel and gas oil. All right. So for hydrotreaters, so for naphtha, we have hydrotreated naphtha punya unit, and going to further downstream unit, and going to the gasoline blending. So this is gasoline blending. I think Sir Fazrul already mentioned this. We have isomerate, reformate. So this is basically gasoline blending punya component. It's not necessarily accurate, but I hope you can get the idea . And then this is for the lighter part. For heavier punya stuff, some of the refiner will have vacuum distillation unit. So why we need vacuum distillation? So basically, the stream going out from the bottom of the atmospheric distillation is very heavy, right? For you to properly separate, you need very high temperature, very high. So in order for us to reduce the temperature required for the separation, we reduce the pressure. We operate in vacuum. So that's why we name it vacuum distillation, right? So vacuum distillation will able to further separate the heavy part or heavy stuff from the atmospheric distillation. Atmospheric, as the name imply, we operate at atmospheric pressure. Vacuum distillation is below atmospheric pressure. And okay, all right. H2 is generated within the refinery plant, or the gas, the waste to gas is purchased externally. It can be both, Siva. So if you notice, all the hydrotreaters will consume hydrogen, right? But then for catalytic reformer, I think the arrow is I think is wrong. Oh yeah, the arrow is not wrong. The arrow is right. For catalytic reformer, they're also producing hydrogen. Some of the refiners, they design a very big catalytic reformer to accommodate the hydrogen demand within the refinery. But of course, they need to process a very light crude. And if the crude is light, so definitely it won't be cheap, right? So then we go back to the margin. Margin will be less. So this is not a good punya approach from economics punya point of view. We have one catalytic reformer. I think this is the only unit that can produce hydrogen. And then if let's say the demand is still higher than what this unit can supply, we can have another unit. We call it hydrogen production unit. So as mentioned, hydrogen production unit feed typically is from natural gas. So natural gas, we convert it to hydrogen, and then the hydrogen will be supplied throughout the refinery unit operations.